Okay guys, make sure you have your notes pulled up and ready to go. You are taking notes with me, following along. You shouldn't be doing anything else on your computers. Start 3.3. I can solve quadratic equations. Now you have seen quadratic equations in Algebra 2, maybe Algebra 1, but we're going to kind of review all the different ways that we can solve them. So that's our goal for section 3.3. It'll take us a few days to get through because there are a lot of different methods. Let's go ahead and jump in. So refresh your memories what a quadratic is. It is an equation. Well, in this case, it's not an equation, but it's an expression where the highest degree is 2. The degree of the polynomial is 2. So we usually form it in the expression ax squared plus bx plus c, where a, b, and c are any numbers we want, any real numbers. Now the 5 main ways to solve quadratics, we're going to cover 2 of them today. We're going to look at graphing and finding the zeros, so we're going to use our graphing calculators today. Hopefully you brought them. If not, you better be sharing them with a friend. We're also going to be solving algebraically. Now you can only solve algebraically when there is no b term. So you have to have ax squared plus c. Okay? So it can only be done algebraically when there's no b term. Other ways, we're going to factor. That will be tomorrow. We're going to use the quadratic formula. And last, we're going to complete the square. So there's 5 different methods we're going to review. But today we're going to cover 2 of them. Okay, so let's jump in. Let's solve algebraically. So notice I have no b term. I just have an ax squared, and I have a constant, but no bx. Okay? So that's when you can use this method. Because make sure you recognize when to do each method. Because when I give you a quiz, I'm going to give you a bunch of quadratics and say use each method a certain amount of times. Like use each method twice. Well, not every method applies to every quadratic equation. So you have to know when to use which method. So once again, you can tell because there's no bx. There's no x term here. Okay, so let's just jump in. We're going to add 14 to both sides. So I'm left with 3x squared equals 108. Divide both sides by 3. I get x squared equals 36. Okay, now a lot of people mess up here and they say, oh, the answer's 6. And they're only half right. Remember, to undo a square, you have to do plus or minus square root. There are 2 different answers to a quadratic. So when you undo that, you get x equals plus or minus 6. Now you can write them separately. If you prefer to write x equals 6 and x equals negative 6, you can, or you can write them together. It does not matter, but it does matter that you have both. If you don't have both, you'll only get half credit because you only have half of the answer. Okay, it's important to note that a quadratic can have up to 2 solutions. Now we're going to look at some cases where it may have 0 or 1, but it can have up to 2. So make sure you undo your squares with plus or minus square root. Okay, so let's try another one. Don't get confused with this minus. It's a minus 1 there. So let's subtract 15 from both sides. Negative 1x squared equals negative 2. Divide by negative 1, we get 2. So now to undo that, we do plus or minus square root. So here you get x equals plus or minus the square root of 2. Couple of things. I don't want decimals. You can find a decimal to check on your calculator if you're comparing to maybe the back of the book if they give decimals. I will always ask for exact answers. So leave it like this. However, make sure it's simplified. Now we know 2 does not tree, but if you need to do your factor trees, make sure your square roots are completely simplified. Other than that, that's it. Now it goes to mention that these are equations. We can check them. So let's check just this one. So I take my answer. It doesn't matter which one. I'll do the positive square root, but I could check them both. I'll just do one. Plug it in. I have 15 minus square root of 2 squared equals 13. So I'm only checking one of the solutions. Well, square to square root undo each other. So I have 15 minus 2. So I have 13 equals 13. There we go. So these are equations. If you have extra time, quizzes or tests, or just even your homework, you can plug them in, check, make sure you're correct. Let's try another one. Okay, first thing we do, subtract 7. So I get 2x squared equals, let's see. Oh, go away, hold on. Sorry. Can't write today. 24. Okay. Divide by 2. I get x squared equals 12. So now plus or minus the square root of each side. So here's what I'm talking about. Here they undo each other. Here we're left with plus or minus the square root of 12. I don't want decimals. I want exact. But we need to make sure it's reduced. So you might have to do a tree. 4 and 3. 2 and 2. So I have a pair of 2's and a 3 left over. Oops. So remember, let me write correctly. Pairs go on the outside, leftovers go inside. So go back over here for our answer. We have plus or minus 2 square root of 3. Now some people do this. They put that plus or minus in front of just the square root, and that is incorrect. We don't want to do that because what that is saying, this is saying 2 plus the square root of 3 and 2 minus the square root of 3. Whereas our answer is saying 2 times the square root of 3 and then negative 2 times the square root of 3. So where you put your plus and minus does matter. Stick it out front. Okay, don't put it in between the two numbers. Oh, by the way, if I'm going too fast, please feel free to ask Mrs. Squares to pause the video. It's hard to tell when you're not in here taking notes with me. Okay. Alright, so first thing, let's add 8 to both sides. We get 16x squared equals 4. Divide by 16. That'll give me 4 over 16. Let's reduce that to 1/4. Now plus or minus the square root. And don't get confused with fractions. We can still do them without a calculator. The square root of 1 is 1. The square root of 4 is 2. Don't forget your plus or minus. So all I did was take the square root of the top, square root of the bottom. By the way, I don't know if I gave you any ones, but shouldn't trick us if I did. What if I gave you something like this? Well, we can take the square root of the top is 1, square root of the bottom is 3, but then like we've been doing, don't forget to rationalize. Okay, so that would be square root of 3 over 3. Okay, so if it doesn't work out perfectly, you can still take the square root of the top and the square root of the bottom, but you might have to rationalize, get that square root out of the denominator. Okay. So don't forget all of that. Okay, so now it's a you try. I'm going to give you a few minutes to try this. Please ask that Mrs. Squires please pause the video. And then when everyone seems to be done with an answer, go ahead and push play. Okay, let's go over this. Obviously we cannot click in today. Negative 5x squared. See, subtract, I get negative 40. Divide by 5. Divide by negative 5, sorry, I get 8. Plus or minus the square root of both sides. So I will get x equals plus or minus square root of 8. I hope many of us didn't forget that that does reduce. Pair of 2's, 2 left over. So I get x equals plus or minus 2 square root of 2. See, a lot of people forget to reduce that 8. Hopefully we did okay, and Mrs. Squires will let me know if there was a problem. Okay, so that's kind of solving algebraically, but once again, you can only use that method when there's no bx term. Okay, so let's move on to graphing. Now, most of the problems we just did had 2 answers. Most of your quadratics you do will have two answers. However, it's not the only option. So the ones we've been doing are parabolas. We know that quadratics look like parabolas. The reason they have two answers is because they will generally cross the x-axis twice. Now that could be concave up, but I can have that concave down. Most of those quadratics are going to cross the x-axis twice, which is why we usually get two answers. But some funny things can happen. Okay. What can also happen is we might have a parabola just floating up there, and it goes on forever and ever up there, or likewise it could be concave down and go forever and ever down towards negative infinity. But either way, this never crosses the x-axis. So here I can have two answers. Here, if it never crosses, that would be a no solution. It never crosses the x-axis, we have no solution. Now, sometimes when you're doing some algebra, you might come across square roots of negative numbers. And for right now, we're going to say that is a no solution. Coming up soon, we're going to take that further, and we're going to still solve that with our complex numbers that we just learned. Okay, but for now, we're going to do baby steps, and just say if I get a negative and a square root, it is no solution. Because that does mean there is no solution on the real numbers. Which is what we're looking at, the real numbers, not complex. Another option, this one throws some people, is if I have parabola that just touches that x-axis once. Okay, that means there's one answer. One answer. And that's kind of harder to find graphically. It's not too bad. But we do have to do something a little differently. So that's where I could barely skim it. It does not cross it, but it does touch that x-axis. And likewise, that could go the other direction. I could have one that barely touches it this way, just once. Okay. Alright, so let's try some on our calculators. Now, this is a little different. This one has no b term, so I could solve it algebraically, but we're going to practice graphing. Okay. So I'm going to show you on the Inspire, because that's the only one I have on my computer, and then I'm going to show you a tiny video for 84s, because I do not have an 84 I can bring up and show you the steps. So I'm going to show you a 2-minute video in a second. First I'm going to show you on the 84s. I want to get this equal to 0. That is the easiest way to do these. So subtract 3 from both sides. You get 2x squared minus 7 equals 0. I want it equal to 0. Okay, so if you have an Inspire, pay attention. Go to your home screen. We're going to graph. It doesn't like me up here, so I'm going to have to use my computer. Type your function 2x squared minus 7. We do not put the equal 0. It's implied here. Hit enter. You should see our parabola. Now they should always look like parabolas because they are quadratics. So I have two zeros. One here, one here. I'll move this aside. All of my commands are in menu. I'm going to analyze the graph. And I want to find the zeros. And I see this dashed line. And I'm going to use my arrows over here. I might have to use my computer because it doesn't like to read me on the... I'm just going to use the arrows and go over. Before my first 0, hit enter. Then go past your 0 and hit enter. Your 0 is automatically going to be written here. Okay, and you see it also puts a dot there, a point, to show you that is where it crosses the x-axis. So what I want everyone to listen to me, 3 decimal places. Minimum, 3 decimal places. So it'd be negative 1.871 when I round. So let's write that down. And I'm going to put x is approximately negative 1.871. Approximately because we rounded. Okay, it's not an exact answer. So now let's go back and find the other one. So I'll do menu, analyze graph, 0. Use my arrows to go before the 0, enter. Go past the 0, enter. And sometimes it kind of overlap if they're close, but you can always move them. By the way, you can get your little arrow by squiggly, 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 and you see your mouse shows up. And a hand shows up. If you hold down that center key, I can't do it up here, but you can. It will close the hand, and then you can use your arrows to move it. Okay, mine won't let me do it on the smart board. Whoop. Sorry, went back. Hopefully it'll show up still. There we go. So my other one was positive 1.871. Let's write that down. Okay, now that is with an Inspire. Now, the 84s and 83s are a very similar process, but I cannot, like I said, I do not have an 84 I can pull up and show you. So bear with me, we're going to watch a 2-minute video on how to find the zeros.
Today we're going to demonstrate how to solve for an x, or the zeros of an equation, with your calculator. The first thing we want to do is go to y equals. In our y1 prompt, we want to type in the equation where we want to find our zero. In this example, we'll demonstrate with 3x squared minus 6x minus 24. And then we'll hit enter once you have your equation typed. Next, we'll press graph. Here we can see that we have one zero and another zero. These zeros are where y equals 0, so they're going to be on the x-axis. So to get the calculator to give us the exact zero, we do second trace, or second calc. We go to number 2 or 0, and then we go to the left bound, to the x-axis, near the 0, and then you want to center the cursor on the bottom side of the 0, or below the x-axis, so that the two cursor points that you selected are in between the 0 value. This is where it's going to search for the 0. When it says guess, you can just ignore it by hitting enter again, and then after that you will get 0 equals, x equals -2. That's your 0 for that equation. But we also have another one, so let's try it again. We'll do second trace, second calc. We go to 0, and then we move our cursor. Now we're going to go to the positive end of the x-axis, and we want to move our cursor to the left bound or below it, and then we want to surround it, and then that one doesn't go all the way, so we'll go ahead and just go, just to be on the safe side, and there we go, x equals 4. If you were to solve these out by hand using factoring, you could also find that this equation that we give here will factor out to 3x plus 2 x minus 4, or zeros of -2.
Okay, we'll pause there. Hopefully that comes back to you. You have done that before. So whichever calculator you use, please know it well, and ask Mrs. Squires can easily help you with your calculators. Okay, so make sure you ask a neighbor to know how to use that calculator. Okay, so let's try another one. 3x squared plus 5x equals 2. Once again, I want it equal to 0, because that's what I'm finding. I'm finding the zeros of the graph. So subtract 2, I get 3x squared plus 5x minus 2 equals 0. So I'm going to put that in my y equals, okay, or if you have an Inspire, the easiest way to get rid of all that is to delete, delete, delete 3 times. So do you want to delete everything? Yes. If you have an 84, you can just clear it out in your y equals. In the Inspires, hit tab, and 3x squared, mine will type. Let me see the rest of it. Plus 5x minus 2. Plus 5x minus 2. Okay, so we should see our nice neat parabola. Hopefully if you're on the 84, you just graphed it in your y equals and hit graph. So now I'm going to go to menu, analyze graph, 0. Go a little bit before the 0. It doesn't matter which 0 you find first. I'm traditional, I like to go left to right. I'm going to hit enter. Enter. Looks like this one works out nice and neat, -2. Notice I'm not giving the y value, because if you're on the x-axis, the y value should always be 0. finding is x equals. I'm finding the x value. So in this case, x is -2. Let's go back and find the other. Menu. Oh, hold on. Analyze graph, 0. If you're on the 84, remember you have to be a little bit below and above, depending on which one is still left and right. A little bit before, enter. A little bit past, maybe if I can move to go. Enter. If they overlap, you can move them. 0.33333. Now, I did tell you round to 3 decimals, but what is that really? Hopefully we recognize that is 1/3. So either answer is acceptable, but I did tell you 3 decimal places, so we'll stick with that. So 0.333. And decimals are only allowed when we do the graphing method. Any other method, I do not want approximations. Okay? Only when we graph are you allowed to give decimals. And once again, we could check these. Plug it in. Let's check one of them. Let's check the -2. I have 3 times -2 squared plus 5 times -2. Hopefully that will equal 2. So I have 3 times 4. We'll go ahead and multiply that. That'll give me -10. So I have 12 minus 10. So 2 equals 2. We could also check by plugging in 1/3. Now if you check your decimals, it may not be exact. You might get 2 equals 1.999. You're going to be close, hopefully, because we rounded our answers. Let's try another one. Let's get it equal to 0. Now you could take the x squared over. I will never do that. I will always want my a term to be positive. So I'm going to take these two over by subtracting x and adding 3. So I'll have x squared minus x plus 3. Okay, so let's go to our calculators. Once again, if you're on an Inspired, delete, delete, delete. Otherwise, in your 84s and 83s, you can just clear out your y equals. Hit tab. So I will have a crazy computer right now. It's a mind of its own. I might have to use the x squared. I forgot it because I was messing with that. Let's see, minus x plus 3. You should be doing this along with me on your calculators. Ooh, get a parabola floating up there above the x-axis. So does it ever cross the x-axis? No. So what can we conclude? Hopefully you're all saying there's no solution. It never crosses the x-axis. There you go. And that is my answer. That's all I need to do. You try. So do x squared plus 4x plus 1. We'll give you a minute. Pause the video. When everyone seems to have an answer and is ready, please hit play. Okay, let me go ahead and graph this. Hopefully we did all right, but let's go over it. Tab. Get x squared plus 4x, I think it was plus 1. Let me double check. Yep. So I have parabola with two nice, neat solutions. So I'm going to menu, analyze graph, 0. I'm going to use my computer to go a little faster here. So I'm going to be before my 0, hit enter, go after, enter, here we go. Negative 3.732. There's a decimal there, it's hard to see. Okay, let's try the other one. Menu, analyze graph, 0. Let's go before the other 0. Oops. Enter. Go past it, enter. If it looks like they overlap, you can grab it, move it. Negative 0.268. Round correctly. 9 rounds out of 8. Negative 0.268. let me pose you another question. What if we had one of the parabolas that just barely touch it? Our zero command is not going to work, because think about it. On either calculator, you have to go above the x-axis and then below, or vice versa, below and then above. So if you don't change above and below, the zero command is not going to work. So what you would have to do there is get a little tricky when you go to menu. Hold on. Analyze graph. Instead of hitting 0, you can find the min or the max. You can find, so if it's a minimum like the one I just drew, you can use that command. And to do that on either calculator, you go a little before the minimum, enter, a little after the minimum, enter. Obviously it has no meaning on this graph, I just wanted to show you the commands. So if you get a weird one that barely touches it, instead of going through it, don't use your zero command, use your min or max. Max command will be needed if it looks like this. That is a max there, not a min. So those are the only tricky ones you might encounter. Otherwise, it should be pretty straightforward. Okay, so homework tonight are handouts. There's 2 of them. And I put them as 2 different assignments in eBackpack so as to not confuse you, and it would be easier for me to grade and for you to submit. So you do have 2 little assignments in there. It's only 1 homework assignment. So in your homework tab, you will find 3.3 Day 1 Homework 1. You've got a person puzzle. These are solving algebraically. Once again, circle or highlight your answers, and then make sure you have work down here. You must have work down here. Now, even though they may give decimals up here, that's fine to help you check it, but all of your answers need to be exact square roots. Okay? Don't give decimals if you're solving algebraically. And by the way, this guy here that you're going to learn about, if you've not heard of, I forget how to pronounce his last name, but if you've not heard of this guy, please Google him. Look up on YouTube. He's got some awesome videos that are just very meaningful and really cool if you haven't seen them before. You may have. So that's the first part. And then you have 3.3 Day 1 Homework 2, your hamburger joke. Now this is where you're going to first look at this graph and say, are you going to have no solutions, 1 solution, or 2 solutions? And then find the solutions. Okay? So over here, you first say how many solutions you're going to have, and then right here you're going to write the actual solution. So you have to graph these and find the zeros. Okay? So you have 2 handouts, the algebraic method and the graphing. Please submit both on eBackpack. Okay? You have questions, please ask Mrs. Squires, and if not, you got your remind text, you can send me a text. Please be careful of the time zones, time change. Okay? Other than that, go ahead and start working on homework.